Okay. Hello everybody. In this video we're going to take a look at the idea of centripetal force. So in yesterday's class and in the last video we were able to find this idea of centripetal acceleration. So we noticed that when objects are moving in a circle at a constant speed, that the acceleration vector is always towards the center of the circle. And so this word centripetal means center seeking. And in the last video, if you missed that, you can go back and check that out for how we derived this expression for centripetal acceleration, so where this v squared over r comes from. Now, if we have an object that's in motion in a circle, so if we have some object that is moving in a circle, let's say, in this direction, this way, then we know that the velocity is constantly changing. Thinking about what we know about acceleration, we know that there must be some net force causing this acceleration. So we know that net force is equal to mass times acceleration. So if there's a centripetal acceleration, then we know that there's some net force causing this object to accelerate. Well, we're going to call whatever this net force responsible for this centripetal acceleration, we call this centripetal force. So you can imagine this is F with a little subscript C. One of the important things to think about is that this centripetal force, okay, is not going to be necessarily from one particular object. So this is not a specific force interaction, but it's the sum of the forces that is causing the acceleration. So something to think about and something that we'll revisit again. Well, if we think about centripetal force, what's the force, net force that's causing this centripetal acceleration, then it's the same thing as saying mass times centripetal acceleration. And we can simplify this even further by taking a look at the math model for centripetal acceleration. So now I have m times, so all I'm going to do is substitute in for this acceleration, the centripetal acceleration, the v squared, right, divided by r. And so we come out with centripetal force is equal to mv squared over r. And so now we have this second math model that we can use for centripetal force.